Okay, so today we're going to practice sketching the derivative from the graph of our original function. Okay, so it's not going to be exactly correct. It's just going to give us an idea of what our derivative looks like and compared to our original function. Okay, because that's a skill that we need to have. It also aligns with our first derivative test. Okay, so knowing what the derivative looks like, we can use that to actually tell us our relative extremas, just like a first derivative test. Okay, so I have this first problem where I have my f of x being 3 cosine 1 half x plus 3. Okay, now again, just like doing a first derivative test, you start with your critical points. You find your maximums and your minimums. So this function has here a maximum here, which translates to a 0 in my derivative. Here I have this minimum, which translates to a 0 in my derivative. Here I have a maximum, which translates to a 0 in my derivative. Okay? So these maximums and minimums are my critical points, and that's where my derivative is 0 or has an x-intercept. Okay? Then I use the fact that my function here is increasing and decreasing to actually create my function, my derivative. Okay? So see how my function here is increasing on the left of this maximum, which means my derivative is positive. So it's going to go like that. And then here it's decreasing, which means my derivative is negative. Okay? Which means I'm going to go down like this, and it's going to come back up. And then here, after this 0, that's where my function starts increasing again, so that's a positive. So it's going to come up here, and then come back down. And then here it's decreasing, so it's negative. So this is what my graph looks like. And if you remember your derivatives, the derivative of cosine is negative sine. But if you look at the way this cosine's been moved over, okay, but if you look at this cosine right here, one period of cosine is from here to here, and you can see where cosine goes like that, this is negative sine. So it kind of matches. All right, so let's look at our next function. Same thing, even though it's a quadratic, we've got a maximum in my quadratic there, which is a 0 in my derivative. Then we use the fact that quadratic is increasing on this side, or positive, in my derivative, and on the other side it's decreasing, which makes my derivative negative. And so there is my derivative. And it makes sense because, again, when we take the derivative, we reduce the power by 1. Okay? All right. Here we have this cubic. So start with our maximums and minimums again. So that's where my zeros are, here and here. Okay, so these translate to my zeros of my derivative, minimum and maximum. So on this left side, it's decreasing, which means my derivative is negative, so it's on the negative side under the x-axis. Here, between the mins and maxes, it's increasing, which means this part is positive. And then it's decreasing on this side, which means this is negative. And again, since I started with a cubic, my derivative should look like the quadratic, which it does. All right, so let's look at the next one. Here we have a cubic. Now, this function here, okay, it has a critical point right here. Okay, this is a saddle point. This is a critical point. Okay, that's where I have a horizontal tangent, where the derivative is 0, equal to 0. There's a horizontal tangent here. So that's still a 0 here. Okay? Now, on this side, my function is decreasing, which means my derivative is negative. So it goes down. On this side, though, on the right side of this horizontal tangent, it's still decreasing, which means it's still negative. And so it's going to look like this. So I still get a quadratic, but instead of it crossing the x-axis, it bounces here, like that. And this is a perfect example where if you looked at the sign chart on this, on one side it's negative, on the other side it's negative, which means it has to bounce there. And that's how you curve sketch. Now, if you layer in the second derivative test, you could keep going until you basically had nothing. So, or 0. For instance, if I did this one again, this point right here, if I took the derivative again, I'd start with the first derivative 0, or the maximum here, and on this side it's increasing, so positive on this side and then negative on this side. So that would be my second derivative. This is f prime double prime. And again, if you wanted to, we could take the derivative again, and since this is just a line, when you take the derivative of a line, you get a constant, so this would be f triple prime. Okay, so we could keep going using these same rules. We could keep going until basically, if we took the derivative again, we'd get 0, we'd get nothing. Okay, but this is really important, especially when we start doing curve sketching, to know how using these basics will actually create our sign chart graphically versus doing it algebraically. And also, there's going to be a point where they give you the derivative, and then we're going to use that derivative and that information to actually recreate our original, or at least find some information that we need from it based on whether it's positive, negative, or 0. But that's for another video.